So we need to talk about the period and the phase shift for this tangent function. So let's do the period first. So the period is how long it takes for its graph to repeat itself. We find the period by first determining what is the period of tangent. Okay, and the period of tangent repeats itself every pi, not every 2 pi, so be careful there. So now what we do is we say, okay, tangent repeats itself every pi, but now this guy right here in front is going to make things happen twice as fast. So what's going to happen there is we're going to have a horizontal compression or a horizontal shrink. So everything's going to move toward the y-axis. So since we're multiplying by 2 here, we want to divide by 2 over here. So what we're going to end up with is pi divided by 2. So the original pi comes from the period of the original tangent function. So that's this guy up top. The 2 down here comes from this guy right here. So since we were multiplying by 2 here, we divide by 2 on this guy right here. I just guess I should put this up here so that it's not confusing. We're going to divide by 2 here. So your period is pi over 2. So this new tangent function will occur. It repeats. Actually, let's put repeat down. Every pi over 2, or every 90 degrees, is going to repeat itself. The phase shift is going to be the movement to the left or the right of the y-intercept. So this is going to be the movement left or right of the y-intercept. How we find that specifically is taken from these two numbers. Okay, and what I'm going to do is I'm going to take the back number and I'm going to divide it by the front number. So it's going to be pi over 2 times 1/2. Because if I do division, it's like multiplying by the reciprocal. So it's going to be pi over 4. So the first point is going to move pi over 4. So let me show you what the graph will look like, and then I'll do it on Maple as well. So what we're going to do is I'm just going to graph out the original tangent function. So the original tangent function, let's do it, I don't know, let's pick a color, let's pick orange. Okay, so tangent of theta in orange. So this is why it's important that you know what the functions look like. So tangent starts at 0 and it heads upward like this. Let me draw it out a little bit wider. Okay, it heads up like this, and of course on this side it heads down like this. It has a vertical asymptote when tangent is undefined, and that tangent is undefined at pi over 2. And so then it's also going to have another 0 value here at pi. It's going to go like this. Okay, and so of course, if we kept going with this guy, it would look like this, and of course on this side, you know, we can keep doing this for as long as we want. Now, the phase shift is the first thing that we want to represent. So let's take, so what we do is we take, I'll do it in green here, we take this guy right here, and he's going to get moved to the right or the left. Now here, he's going to get moved to the left because this guy is positive. So this was a left movement. Sometimes people will just put a negative up front here, okay? So it's to represent the left movement. So the phase shift is negative pi over 4. Okay, or you can say left pi over 4, however you want to say it. So we know that this asymptote right here is at negative pi over 2. So pi over 4 is right in the middle. Okay, I'll make some dashes in here. So this guy jumps back to here. That also means, so now when we do our, I should say that also means, but when we do our period, this point moved over to here. Now how long does it take to repeat itself? Well, that's basically the length between the asymptotes. Okay, so let's take a look at, we're going to try to repeat ourselves every pi over 2. So the length, this length that used to be from negative pi over 2 to pi over 2, it used to be a length of pi, right? That was this over here, the old period. The new period has to be pi over 2. So I'm going to go to the right and the left of this guy by pi over 2. So this guy was at negative pi over 4. Now I need to go to the right by pi over 2. So let me do the math out here. Negative pi over 4 plus pi over 2 is the same thing as negative pi over 4 plus 2 pi over 4, which is going to give me positive pi over 4. So at pi over 4, which is right here, I'm going to have, this is pi over 4, I'm going to have my vertical asymptote. And now the next one is going to occur at, let's see here, I'm going to wrap my pen. Okay. The next one's going to be negative pi over 4. Now I need to go the other direction, so we're going to subtract. Oops, I did that wrong. That was looking too wide. See? Even I make mistakes. Okay, so let's redraw this guy back up in here. So negative pi over 4, it's got to repeat itself every pi over 2, which means that I need to go to the left or right by half of that distance, right? So before, this length right here, this normal movement over here was by pi over 2, and that's what this is right here. And then this normal movement was by pi over 2 as well, which is why we got negative pi over 2. So I only want, for between my lines, let me just draw this out over here. Between my lines, I only want this guy to be pi over 2 because that's how long it's going to take to repeat itself, like this. So I need each of these guys to be half that, which is pi over 4. So I'm going to add and subtract pi over 4 to this guy. Well, when I add pi over 4, I end up at 0. So this guy, this looks much better, is at 0. And then this, I go to the left by pi over 4, which gets me at negative pi over 2, coincidentally. And so it looks like that. So this is going to come up like this and come down like this. And of course, we repeat ourselves every pi over 2. Well, not every pi over 2, but I'm sorry, every pi. Well, yeah, every pi over 2. I said that right. So here, my next one is going to occur here. It's going to come up like this and down like this. Now the next one is going to be between pi over 2 and pi. It looked like it got thinner, but that's just kind of how I'm drawing it out. But that's what it looks like. Now let's go ahead and check Maple and make sure that we get the same looking graph off of that. So the function here is the tangent function. So we want to plot the tangent. So I'm going to do the original here in blue. So I'm going to go from negative, let's do negative pi over 2 to, let's go to, out to pi. And I'm also going to change my y value so that I can see just a little bit more. So I'm going to go from -4 to 4. Now for, so that's going to be A. Now for B, we're going to do the new function, which is the tangent of 2 times theta plus pi over 2. So we're going to also use the same values there. So negative pi over 2 to pi, and y is from -4 to 4. And there's an issue somewhere in here. Okay, so this is the original tangent function. And if we go back and we look at our graph between 0 and pi, the original one, which is the orange one, would have looked like that. Okay, so that looks good. Now we want to graph the second one. And when we do that, I want you to notice again that I've got vertical asymptotes at -pi over 2 and at 0. And if we go back and we look at that, the green one has asymptotes at -pi over 2 and at 0. So here's that green graph. Let me grab this marker again here. That green graph shows up, do it in red, in this range. And that is the same as this red line right here. And so again, we're going to repeat ourselves every pi over 2. So when I go out to just pi, okay, so just out to pi, I'm going to see one more here, and one more here, which is what I'm seeing here and here as well. So what this allows us to do, guys, if you haven't figured it out yet, is I don't have to plot a whole bunch of points. What I can do is I can use the parent function, and I can move it using the period and the phase shift to get the new function.